Hey everyone, and welcome back to the channel. Today, we're diving deep into a fault code that can really throw a wrench in your day. SPN 102 FMI-II. If you've ever seen this pop up on your heavy equipment, you know it's related to the intake manifold pressure sensor. But what does out of range really mean? Don't worry, by the end of this video, you'll know exactly what this code is telling you, what causes it, and how to fix it like a pro. So, let's start with the basics. SPN 102 identifies the component, which in this case is the intake manifold pressure sensor, also known as the boost pressure sensor. FMI-II is the failure mode identifier, and it means data erratic, intermittent, or incorrect. Essentially, the engine control module, or ECM, is getting signals from this sensor that just don't make sense. The voltage reading is either too high or too low for the current engine operating conditions, or it's just jumping all over the place. The ECM expects a certain pressure reading based on engine speed and load, and when the sensor signal doesn't match those expectations, it flags this code. What are the common symptoms you'll notice? The most obvious one is the check engine light, or malfunction indicator lamp illuminating on your dash. You'll likely experience a significant loss of engine power, almost like the machine is in a derate mode. This is a protective measure by the ECM to prevent potential engine damage from what it thinks is an abnormal boost condition. You might also see excessive black smoke coming from the exhaust. Notice a decrease in fuel efficiency, and the engine might run rough or even hesitate under load. These symptoms all point to the engine's air-fuel mixture being off, which is exactly what happens when the ECM can't trust the intake pressure reading. Now for the big question, what causes this fault? The possibilities range from simple to complex. Let's start with the sensor itself. The intake manifold pressure sensor could simply be faulty. Over time, sensors can fail internally, leading to erratic signals. But before you rush to replace it, we need to check the basics. A very common culprit is the wiring harness and connectors. Look for any signs of damaged chafing, rubbing, corrosion, or bent pins in the connectors. A loose connection or a damaged wire can easily cause an intermittent and incorrect signal, which is the classic definition of FMI-II. Another potential cause is a problem with the sensor's power or ground supply. The sensor needs a stable reference voltage, typically 5 volts from the ECM, and a solid ground connection to work correctly. If either of these is compromised due to a wiring issue, the sensor's output signal will be skewed, triggering the code. Don't overlook physical issues either. The sensing port on the manifold, where the sensor screws in, can get clogged with soot and carbon buildup. If this port is blocked, the sensor can't get an accurate pressure reading from the intake manifold, even if the sensor itself is perfectly fine. So, how do we troubleshoot this? Start with a visual inspection. Check the sensor, its connector, and the wiring harness leading back to the ECM. Look for any obvious signs of damage, moisture intrusion, or corrosion. Clean the connector terminals if they look dirty. Next, with the engine off and the key on, use a multimeter to check for that 5-volt reference at the sensor connector. You should also check for a good ground connection. A voltage drop test on the ground circuit is a great way to confirm its integrity. If the wiring checks out, the next step is to remove the sensor and inspect the port for any blockages. Clean it out thoroughly. While the sensor is out, you can inspect it for physical damage. If everything still looks good, you can test the sensor's signal. Using your diagnostic software, monitor the intake manifold pressure reading with the key on and the engine off. It should read close to the current barometric pressure. As you start the engine and increase the RPM, you should see the pressure reading rise smoothly. If the reading is stuck, erratic, or doesn't change with engine speed, it's a strong indicator that the sensor itself has failed. At that point, replacing the sensor is your best bet. Fixing SPN 102 FMI-II is all about systematic diagnoses. Check the easy stuff first. Visual inspection, cleaning connections, and verifying power and ground. This will save you time and money. Only after ruling out wiring and blockages should you condemn the sensor. By following these steps, you can confidently diagnose and repair this common fault code and get your heavy equipment back to performing at its peak. I hope this guide was helpful. If you've dealt with this code before, share your experience in the comments below. What was the cause in your case? Your insights could help someone else out. Don't forget to like this video if you found it useful. and subscribe for more deep dives into heavy equipment fault codes. Thanks for watching, and I'll see you in the next one.